Now it's on.
Okay. All right. I now have my magic markers and I'm ready to begin.
Hopefully it doesn't fall.
Last week, we began talking about basic supply and demand curves. We have an X and Y axis with price and quantity, a positive slope on the supply curve, which is defined by the business or the firm, and the downward slope of the demand curve defined by you and I, the consumers. And we have a well-defined equilibrium where quantity supply equals quantity demand. When we looked at this last week, we were focused on the movement of the curves, left and right. If we had an increase in supply, we would move to the right. That'd be an increase in supply. And if we had an increase in demand, it would be a movement to the right as well. We're going beyond that now. Now that you understand what makes those curves move to the right and to the left, and what impact it has on P and Q, we're going to throw another variable in there. It's called elasticity. And then deals with responsiveness of X. Changes in Y. So it wants to understand how price affects quantity. The curves are not always at a slope of 1 or negative 1. We can have situations where the curve, the demand curve, is perfectly elastic and perfectly inelastic. This is a perfectly elastic curve. In this situation, let's say the price is $1. If the consumer asks the business to sell it for 99 cents, what are they going to get? Nothing. If they're willing to pay $1, how many units will they receive? An infinite number of products. Infinite supplies. At $1.01, it's infinite. But at 99 cents, it is zero. They will get nothing. Because with this perfectly elastic demand curve, both the business and the consumer, there's so many of them involved, they believe they have no control of the marketplace. They perceive this curve to be perfectly elastic. And they have no or zero control of pricing. If we want to talk about responsiveness, if it can go from infinite to zero, that's highly responsive. Now in this case, let's say I have a perfectly inelastic curve. This is perfectly elastic. And this is perfectly inelastic. Inelastic. Let's say the quantity for this product, this demand, is 2 units. We can have a situation where we have a perfectly inelastic demand curve. Let's say there's a disease that's going around and you cough twice in the morning and you're dead the next day. And through careful research, I have found a cure. And it takes 2 50-milligram pills to cure you. How many pills do you want for $10? $100. $1,000. You want two, 100,000. You still want two. Now, the higher the price goes, it will eliminate people from the marketplace, but they still want two even though they can't receive them. That's a perfectly inelastic curve. We can see a perfectly inelastic curve in the supply side as well. Just like we have elasticity in supply and demand, we have elasticity in supply. Let's say this is Q. Let's say this is NC State's basketball arena. I don't remember how many holes. It's around 18,000, I believe. The supply is set. It's perfectly inelastic. It's not like they're going to add or subtract seats in the middle of the night. That's set. It's set by fire code and everything else. Now, what we want to do is make sure, if I'm the AD, I want to make sure all these seats are paid for. Regardless if you desire to attend. So what I do is, if I know everybody wants to go to the UNC game, and a few people want to go to the Wake Forest game, and nobody wants to go to see UNCG, which beat us. UNCG. And I'm glad I didn't go. But if I want to make sure all the seats are filled and I'm maximizing my profitability, I'm going to look at each one of these curves. Let's say this is $100 a seat. This is $25 a seat. And this is maybe 10 to fill it up. I could sell a package for $200 or we'll say $175 for all three games. And based on this game, I can sell out all of my seats. Now, as a basketball team, you want to see all the seats filled. But as an AD, I want to see all the seats paid for. One thing that will help them is if they have season tickets sold. Because that's going to do what? Raise each one of these points and raise the price of the goods. That's where you see a perfectly inelastic supply curve. There's no more available than what you see there. Let's go to elasticity, and we're going to calculate elasticity using the midpoint formula. The midpoint formula is this. Elasticity of demand equals the absolute value, percent change in quantity over the percent change in price. Remember, we're looking for the responsiveness of X to changes in Y. So let's graph some. We go P, Q, is quantity demand, 5, 4, 3, 2, and 1. 1, 2, 3, 4, and 5. When we get to that, you'll understand a little more once we get everything set up for graphing. I have P and I have Q. 2, 3, 4, 5. I'm also going to create a second graph underneath of this one. The x-axis will be the same for both graphs. The y-axis will be different because I'll be calculating total revenue. You have a little straight line here. The x-axis will be the same as we see up at the top. Since I've already done this problem, I know I'll just scale this one. All right, first thing I'm gonna do is calculate total revenue. Total revenue is quantity, price times quantity, is total revenue. So 5 times 1 is what? 5, and 8, 9, 8, and 5. So we have created a parabola. We'll see it increasing. 5 and 1, 8 and 2, 3 and 9. 4, and 5 at 9. So if I draw this graph, it'll look something like this. That's my total revenue curve. And we'll come back to that momentarily. Now I'm going to draw the total revenue curve. Price of 5, they want 1, 4 and 2, 3 and 3, 2 and 4, 1 and 5. And this is my demand curve. I'm going to label it A, B, C, D, and E. Because I'm going to measure the elasticity between every point on this graph. Yes, sir. You get it set. All right. So far, does anybody have any problem with what I graphed and the calculations that I did? Okay. Now we're going to bring in the midpoint formula. And I'm going to measure the elasticity from A to B, the responsiveness of X to changes in Y. So from A to B, using that formula, this can be 2 minus 1 over 2 plus 1 divided by 2 over 5 minus 4, 5 plus 4 divided by 2. It equals 1 over 1.5 over 1 over 4.5 equals 1 over 1.5 times 4.5, 1 which equals 4.5 over 1.5 which equals 3. So my elasticity demand between these two intervals is 3. That's telling me for every percent I change the price, I see a 3% change in quantity. So quantity is highly responsive to changes in the price. Therefore, I need to lower the prices to take advantage of that additional quantity. That was A to B. You know that you put B up there. Then you go B to C. 3 minus 2 over 3 plus 2 divided by 2 over 4 minus 3 over 4 plus 3 divided by 2. That equals 1 over 2.5, 1 over 3.5, 1 over 2.5 times 3.5 over 2 over 1 gives me 3.5 over 2.5, and that gives me 1.4.
Okay, I'm sorry.
I'm so lost. I have no idea.
Well, usually the class lets me turn around and ask the question. I'll go to the screen. Y'all are not going to give me that time. I do this to intensely confuse you. To where you know what questions to ask. Where do I need to start?
At the beginning.
At the beginning. Okay. Here we go. From the beginning. I'm going from A to B. So this is A, B, C, D, E. That's how these points are defined. So the first example, the first equation I create is from A to B. It's the percent change in quantity over the percent change in price. So the first thing I must do is determine the distance between these two intervals. How do you determine the distance? You subtract, correct?
Mm-hmm.
What did I do? I subtracted.
Yep.
And then I divide it by the average. Because remember, I'm after the midpoint formula. So I need this point right here.
One
So
and
I'm
a
going
half.
from A to B. And I need this midpoint. So to find the average between these two intervals, what do I do?
Add them and divide by 2.
Add them and divide by 2. That's exactly what I did. I added 2 plus 1, which gives me what?
3.
And I divided by 2,
1 and a half.
1.5. That's exactly what I did. So do you see where those came from? Remember the X's on the top. Now we're going to do the same thing over here for Y, or price. First thing I need to know is the distance between those two intervals. How do I do that? I subtract. 5 minus 4 equals what?
1.
1. And I'm going to divide it by what? The midpoint, just like I did on the x-axis. So now I'm looking at this point right here, and it's going to tell me the elasticity right here. That's the midpoint. So I've got everything set up in the equation. Is everybody good to there? Where do I need to go? Which part?
I don't know.
Do you see-
I'm not gonna be that person that's gonna be like, I'm not.
Okay, well, here's what I'm gonna do. For X, first part, I'm gonna find the distance. Let me get another pen, I don't know if that can be seen. We're gonna set it just like the equation. Let's say X1, we find the distance. And we divide it by X, the average. And then we divide that by Y, the distance. Divided by Y, the average. The process is the same, the numerator and denominator. We're doing exactly the same thing, but we're dealing with different axes. Because this is the midpoint we're after. So like I said before, we start out finding the distance on which axis to start the problem? On X. So let's go C to D. Where do you think we start? Where do we start? C to D. X or Y axis? X axis. Because we can see that up there, change the quantity over change the price. So that's the X axis. So the first thing I need to know is the distance between the 2 points. From C to D. How do I get the distance?
4 minus 3.
4 minus 3. Divided by what? Who knows?
4 plus
Look,
3.
look what we got. It's going to be 4 plus 3 divided by 2. Make sure you put it in parentheses because it's not 2 divided by 2, it's 5 divided by 2. Is everybody good with that? You see where it's coming from? That's the x-axis.
So it,
Wait a second. Yes, ma'am.
Oh, no, I ain't raised my hand.
You see it?
I'm gonna just do some tutoring, that's okay.
Okay.
Just good to see.
Yes, sir.
so whatever's on the top is to be subtracted, and whatever is on the bottom is to be added. It doesn't change.
It's constant. See it?
Yeah. That's
Constant.
what I'm saying. Like,
Yep.
it's supposed to be subtracting like the midpoint.
Yep. Because that's what you're finding is the midpoint.
And the 2 is supposed to be divided by 2
Yes.
to find the average.
Well, you add the two numbers and you divide by 2. And it'll give us this point right here.
Yeah, I'm saying it's never gonna be a 3 or a 4. It's always gonna be a 2.
Oh, division?
Yeah.
Yes, it'll always be by 2, yes. Now, these numbers can change.
Yeah, I know, but those numbers can change, but
That format is not gonna change. Okay? And then it's gonna be divided by what?
3 minus 2,
3 minus 2 over
3 plus 2,
plus 2 divided by what?
2.
We now have everything we need. Everything from this point forward is basic math. 4 minus 3 is 1, 4 plus 3 is what? 7
7.
divided by 2
3.5.
over
1.
1 over
2.5.
2.5. So when you're dividing fractions, you can also multiply by the reciprocal.
Yep.
So I'm going to bring down 1 over 3.5 times 2.5 over 1. That is multiplying by the reciprocal. That's going to be 2.5 over 3.5. And that will equal 0.714.
Can I take a picture of that?
Oh, yeah, well, let me finish before we take a picture. You want to smile? All right, let me get out of the way, so you can take your picture. All right. So we now know that the elasticity between B and C is 1.4. The elasticity between C and D is 0.714. If we complete the D to E, what is that going to give us? Well, how do we start that? Doing the math. 2 minus 1?
No.
4 over what? Plus 4 divided by 2 over. Now we can go to 2 minus 1 over
2 plus 1.
2 plus 1. See, it's catching on. Divided by 2. And then all we have to do is the math. And if we do the math, I will tell you that it's 0.33 to infinity. So the elasticity between these two intervals is what? 0.33. So if I change the price 1%, I'll only see a 0.33% change in quantity. So there's no incentive for me to lower the price. There's only incentive for me to raise the price. If the elasticity is 0.714, there's only the only thing we need to do is raise the price and lower the quantity. Because the point we want to be at is right here. The elasticity demand is equal to 1. That's where we want to be. If we have any numbers greater than 1, we need to lower the price and increase quantity. If your chief financial officer comes into your office and says, our current elasticity demand is 0.832, what do you need to tell them to do? Raise the price. Now, this is it's like a unicorn. It's always being chased, but it doesn't really exist because we're always going to be going back and forth across 1. Because things change every day. The equipment changes. The personnel changes. So this is the number we're always shooting for. But if we're down at 0.33, we definitely have a serious problem. And we need to get back to here. Now, when we look at this curve, the slope of this curve is what? The rise over run, what's the slope of this curve? -1. Because you go down 1, -1, and you go across 1. The -1 over 1 is -1. So we have a straight line here, and I can calculate elasticity as it changes along that curve. The reason I drew this curve underneath This will help you just as much as understanding this when you get to the test. Because what is occurring at this point where elasticity demand is equal to 1? What's happening here? We've maximized total revenue. Over here, as we see total revenue increasing, you have an increase in total revenue. What condition exists for elasticity? If increase in elasticity demand is greater than 1. If you see it's decreasing, you have a decrease in total revenue, your elasticity demand is less than 1. And the reason this will help you on the test, let's say they give you two numbers. Let's say they tell you at a price of 5, they want 10, and a price of 4, they want 12. What condition exists in elasticity? Or what is the elasticity for this interval? How responsive is X to changes in Y? Just calculate your total revenue. Total revenue will be 50. And what?
36.
48.
40, well, 48.
48. Okay, so what direction are we moving on total revenue? Up or down?
Down.
And the number's very small. So I would assume, which I can automatically eliminate any numbers that are positive in elasticity. So let's say it has A, B, C, and D. 1.8, 1.27, negative 0.43, and negative 0.8. Based on this information, I know that these numbers exist somewhere in that area of that total revenue curve, or any total revenue curve that's a parabola. Because the number is what? It's decreasing. And it's not a large interval. So I can automatically say that these two are not it. Now I've reduced it to two possible solutions. If I saw a large number change, like from 48 to 26, I'm going to think it's more on this end. That'd be an educated guess. But with these two so close together, I'm going to assume that it's probably D. So understanding the total revenue and its relationship to the demand curve and elasticity will help you on the test. You could still do your math, and what would it be? It'd be 12 minus 10 over 12 plus 10 divided by 2 over 5 minus 4 over 5 plus 4 divided by 2. So either way, you can find a solution. Once you have this inputted, it's all basic math. Have your sheet beside you. Have this information with you. Now, what they like to do is a little bit different. They determine the percent change here by itself, and then percent change here, and then they divide. That's okay too. That's a simplified form. Because all they're doing is they're doing the math here, and here, and then they're just assigning it later on down the road for the solution. With the midpoint formula, you take it all the way out. But there's some rounding issues in there. So if you have an answer that's 0.81 and your response is 0.808, 8.08, you know it's the correct answer. They won't have any that close together. We just need a basic understanding of what happens with elasticity. Questions? Good? Yeah,
Me?
yeah,
Yes.
good? We good? Well, back here, it's been quiet back here. Good? All right. If you have any questions, you need to stop me. Otherwise, I'm gonna keep going. Did you want a picture down?
I already took
Oh, you got it.
Sorry.
So now we're gonna raise the entire board and we're gonna talk about the determinants of elasticity. Just like we had the determinants of supply and demand, it's the same thing. When we look at the elasticity of supply, if it's greater than one, it's elastic. If it's less than one, it's inelastic. So the same thing applies to supply, the quantity supply. Okay. We'll draw two curves. Well, actually four. So you can see the difference in what is happening to total revenue when we have elastic and inelastic curves. If we have an elastic curve that looks something like this, we're going to see the total revenue curve is going to look like this. And it's still going upward. Because the point where elasticity demand equals 1 is going to be somewhere out here. So that means that everything out here, the elasticity demand is greater than 1. And it's elastic. Let's say we change the price. Let's say we add a tax. There's our price 1 or price 0. There's price 0. And there's quantity 0. And here's our total revenue. 0. If we raise the price, or if the government applies a tax to our product, look at what happens. Not only quantity, the total revenue falls as well.